What is the basic difference between AR, VR, and MR?
You're fully immersed 100% CGI. Some people treat X as like the variable, where it's like blank reality. Other people say it's extended reality.
How long has this technology been used in construction?
VR was not head mounted. It was actually what was called a cave system. The other massive paradigm shifts is we've also then cut the cord to computers.
What would be some general use cases
To review 3D BIM,
What are the barriers to entry?
getting trapped with the very technical users. I hear this term a lot and I love it. Hollywood BIM.
Benefits for the project managers or the supers?
Who is going to use it, when they're going to use it, and what they're going to review.
The ROI on these technologies, how you measure it.
Typically in avoided rework.
Prerequisite data that they need to capture.
It's not like people need to change the way they model. Now we are in a Navisworks model. Simulate things that a human has to do. Add speech to text annotations.
What does the future look like?
Apple entered the game. Whether you believe in the metaverse or not, Mark Zuckerberg and Meta are pouring billions of dollars into the R&D.
In this episode of Constructing Tomorrow, we have Angel Say. Angel is the co-founder and CEO of Resolve, a VR construction software. He has a decade worth of experience building XR applications. They were the first VR company to be accepted into the prestigious Y Combinator accelerator in Silicon Valley. In this episode, we discuss what is VR, AR, MR, and XR, barriers to adoption of VR tech on construction projects, the why, what, and how behind using VR tech, how to measure the return on investment for this technology, a small demo of using VR and walking through a Navisworks model, and the future of XR tech in construction. With that said, I bring you Angel. Angel, thanks for being here and welcome to the podcast.
Thanks for having me, Sid.
Yep, I'm super pumped for this conversation, especially because we're doing something different in this episode. Obviously, we're going to have our podcast style conversation, but then we would also have a small segment where Angel is actually going to help us guide through a demo project, and we're going to use our VR headsets, and he's going to show us some of his cool features that we could use in Resolve. But before we go into all the great things that we're going to learn about VR and how we can use it in construction, Angel, if you could talk about what is the basic difference between AR, VR, and MR?
That's a great question. Very excited to answer that one because I see people mix them up all the time. I've been working in we'll call it the XR space, which I'll also define for the last decade, always helping AECO companies, take advantage of the technology. So I've really cut my teeth understanding BIM workflows, understanding design and construction processes, and then of course how you can apply XR technologies, immersive technologies to some of the common challenges the industry faces. Let's talk about the different flavors of reality, so to speak. So XR, that's the all-encompassing term where, X, some people treat X as like the variable, where it's like blank reality. Other people say it's extended reality, but really XR is like one of the all-encompassing terms. And now virtual reality, VR, that is where you put on some sort of head-mounted display or HMD, and it's going to take up your entire field of view. So everything you're seeing is completely simulated. It is all pixels of reality that does not exist physically in front of you. So you're fully immersed 100% CGI, so to speak. And then there is mixed reality, which is where you have the real world, and usually, the trend now is having more pass through, meaning that the world is being fed to your eyes via a camera, and then you overlay content on that reality. That content can be 3D, it can be BIM, it can be 3D models of equipment, but it can also be 2D data that's not there. And if you've seen a lot of the Meta or Apple videos, one of the things they always show is, you put up screens. It could be a television, it could be a web browser window, but basically floating data that's not actually there. And the last one, augmented reality, AR, very similar to mixed reality. I think, those two are probably interchangeable, unless some people use MR for more pass-through based AR. And then AR is reserved for when you can truly just see the world in front of you. And again, just like MR, it's a mix of digital content and physical content. Think of devices like the HoloLens or Magic Leap. These are more traditional AR devices where they use what's called waveguide displays to basically let you see the real world, but then project digital data in front of your eyes so it looks like it's on top of the real world. So that's a quick, XR 101 for anyone listening.
Yep. And these technologies have obviously gained a lot of traction in the recent times, especially because of the prices of these headsets being affordable now, and the use cases for all of these VR headsets has been mostly in the entertainment industry, or if you want to play games, or if you want to watch movies. But obviously the topic of discussion is construction here. So for how long has been this technology being used in construction?
Oh, really long time. I think it even predates, when I started working in it. So I got involved in the space in 2014, right around when the Oculus Rift, it was called the DK1 at the time, the development kit, the first version of it. And that's around the time when I started exploring the space, and I talked to a lot of people in the industry who were dabbling in it. But if you look back at the history of VR and AR, there have been very sophisticated and expensive systems that have existed for much longer. One of the common enterprise applications of VR was not head mounted. It was actually what was called a cave system, where you would actually go into a room and you had four walls, or sometimes not even straight walls. It could be curved. But basically, um, a system of walls where you're projecting onto it, and sometimes you put on glasses, sometimes you don't, to see it in 3D, but basically you are in a room and then stuff is being projected at what appears to be a one-to-one scale, and then you're free to look around, and everyone's walking through together. So there have been systems like that way before we had these more commercial off-the-shelf headsets, and then even military applications of AR and VR, where we had a lot more enterprise grade devices. They were not accessible. They had massive computers powering them behind the scenes. There were laboratories where you had to go to run this stuff. So it's been in the space for a really long time. Really, the paradigm shift has been, it's now backed by more commercial companies, and any consumer can walk in and get one of these devices from a local electronics store, or order it on Amazon. And now we're talking about devices like the Quest 3, which is in the hundreds of dollars, right? It's $500 for a Quest 3. And the other massive paradigm shift from when I started working in the space is we've also then cut the cord to computers. So, just a quick primer on how this technology works. It's like if you play a 3D game on your computer, there does need to be some sort of processor, both for the computation but also the graphics rendering. That has to happen somewhere. When I started in 2014, that somewhere was a gaming computer. If you're in the BIM space, you're probably familiar with these massive gaming laptops that everybody was buying, or gaming desktops, the Alienwares, the Razers, crazy LEDs everywhere, and you had to roll in with a cart and your laptop and then plug in probably a Vive or a Rift in 2014, set it up. That was like the cutting edge at the time, and we needed that GPU to render stuff because that's what all the manufacturers were doing. But then you sort of started to see that change in around 2017, when you had devices like the Oculus Go, and then followed up by the Meta Quest 1, where all the rendering, all the computation happened on the device itself. You no longer needed a computer. The challenge that came with that, though, is to be able to fit a chip on someone's head and cool it, it had to be pretty small. So it was not as powerful as your NVIDIA GPU on your computer. So that's a bit of a history of where in construction and design specifically how VR has evolved from these massive rooms that you used to have a long time ago that cost hundreds of thousands of dollars to now a device that you can buy from a local retailer that costs hundreds of dollars.
Yeah, and we will get to the barriers to entry, but before that, what would be some general use cases that come top of your mind in construction?
So I see lots every day from our customers at Resolve. The primary one is to be able to review 3D BIM in a more efficient way. What I like to remind people of all the time is construction and design is so primed for the use of this technology because this industry is already producing 3D assets, right? It's not like you're having to go out of your way to make 3D assets from scratch, hire an artist studio to make 3D models for you. The industry in the last few decades has moved towards BIM, and I know not every project is using BIM, but that's the general trend. And so these 3D files are already there. We just need ways to bring them into VR. And the beauty of VR is, it is all based on 3D digital data. And so if you already have that data, so many use cases, so many things you can do with it. But if we sort of focus on what Resolve does, it's really being able to walk through your building before it's actually built and put together punch list pretty much of items that you would be wanting to fix during construction walkthroughs, but instead you're fixing them, months or weeks in advance when it's all digital and you can say, hey, how are we going to access, that valve up there? And when you're asking that question, you're entirely in a virtual version of the model, and then fixing it is just, going back to Revit, changing a few parameters, and then voila, your valve is more accessible. And now you just saved yourself rework costs, and you saved yourself the potential inefficiencies on the owner's side from not being able to access a valve and increasing your OpEx or putting people in harm's way. So that's one of them. I think a more generalized answer here is also a lot of people think that VR is really good for. I'll hear them say clash detection, and I like to stay away from that because Navisworks is pretty good. It's like automated for clash detection. Of course, there's always clashes here and there that maybe slip through the cracks, and you can find them in VR. That is true, but I like to remind people that VR is going to augment, and I don't mean that in the augmented reality sense of the word. I mean like it's going to supplement your existing Navisworks flows to help you catch a lot of non-clash issues, a lot of operations, a lot of accessibility, safety, these things that aren't always the focus of coordination meetings today, but that end up biting a lot of projects. Once you're doing your final walkthroughs, once you're going through turnover, and people are walking through and saying, "Hey, why is that built that way?"
And you mentioned that BIM is, for the most part, is being used on almost all the projects, but VR adoption is not really at that scale yet. What do you see are the barriers to entry, or what are some of the challenges which is refraining companies to adopt it that easily?
It's a good question. I think historically it has been the accessibility of the devices. When I first started working on this with my co-founder in 2014, a lot of our customers needed these massive laptops, and so what that meant was that VR was getting trapped with the very technical users. This is something we always talk to our customers about, and once they see it, they're really surprised. VR tends to not, how should I say this? VR takes off with a lot of quote unquote non-technical people, right? Of course, like the BIM, the VDC folks, they gravitate towards it because it's in their area of expertise. But some of the people who end up loving it are the people who are usually very tech averse, but they have so much amazing field knowledge. And putting them in VR finally makes BIM more accessible to them, right? Because they can be walking through the model and be like, oh, yeah, like I remember from the last site, this is how we did this. And now I'm seeing it and I'm standing right in front of it, and they can give you better feedback. And so I think by removing the need for these intense laptops and needing to install all these drivers and Steam, you open it up to a lot more people. And usually one of the barriers is just getting the device on their head. Once you get it on their head and they start to see things and it clicks, they won't give you your headset back. So just getting people to try it, and VR has this stigma. One of the challenges that we face is some people in the industry tried VR 5+ years ago when it was very complex. It was a lot more laggy. I don't know what software they tried. And it gave them a really bad impression of the software. And so then we have to do some work to convince them of, hey, it's a lot easier than you remember. You're not going to burn hours, prepping models just to get them into VR. And of course, here I'm doing a little bit of pitching for what our software has fixed and how it's lowered some of the barriers. But these stigmas that people have for VR sometimes get in the way of them embracing it again because they tried it, a decade ago, and the technology looks so different now. And yeah, so that's one of those things that I think also just gets in the way. Is sometimes people have this impression that that it's difficult to use, that it will make them motion sick, that it's laggy, all these things that I think have drastically changed in the last few years. And the other thing I think I'll say is early on, VR got a lot of traction as a marketing tool. And so a lot of people pigeonholed VR as, hey, we're only going to use it when we go out to bid for massive projects, right? We're going to show it to the developers, show them, like, I hear this term a lot and I love it, Hollywood BIM, right? Show them the 3D model where the glass is so shiny and you have, water that's sparkling and everything looks great. And then after you win the bid, put your VR headset away for another few months. And so it kind of, that's one of the barriers. It's like, oh, VR is just good for marketing, but there's so much data that says otherwise. I mean, one of the studies on our blog is there was a group of researchers that did a study recently where they compared two buildings. And in one building, they used VR with Resolve and the MetaQuest. And then in the other building, they didn't. So they had this control. And they ended up finding way more like operations and maintenance issues in the building that did use VR than the one that just used Navisworks. It was something like 96% of the issues that they found in the building where they use VR were not found in the other building. So, the data's there. It's super, super valuable for more than just marketing. And I think that reputation that it has is one of the barriers to adoption.
Great points you covered. And I think I personally feel that one other barrier might be just education. I think there also isn't enough education about the advantages of it. I think, like, from the outset, it feels like, oh, it is all complex. But I think if you really dig down into how much benefits it might have, I think I think it's just about how easy it is to adopt this technology. I also wanted to talk about what are some of the misconceptions. Like you mentioned, it is more catered towards or more attracted towards the BIM VDC folks, but in the hindsight there are a lot of benefits for the project managers or the supers as well. So can you highlight an example where a project management team and a field management team is using this technology to just improve their workflow?
Yes. I think in terms of misconceptions, maybe this is more of a mistake that I see a lot of construction teams make is just like any construction technology, you can't just buy the hardware and software and then say, hey, we got it, come use it, right? You do need to be deliberate about how you deploy it. You need to know who is going to use it, when they're going to use it, and what they're going to review. And sometimes I do meet teams where just like, we want VR, they buy it, and then 3 months go by and they're like, hey, no one's picked it up. And we're like, okay, great, like, let's go through your plan. Where are you implementing it? Where does it fit into your BIM execution plan? They're like, oh, we just have it in a room and we tell people to come check it out when they want it. And the reality is, like you said, there is this education barrier. And so you can't just expect that people are going to knock at your door and say, hey, I want the VR headset now. They need to know what it's good for. And so that's part of what we try to do. And so, one story I can share One of my favorites is on our blog as well. We have a case study from Fortis Construction. They were working on a massive data center out in Singapore. And what I really love about this case study is it's not just one or two headsets that they put in a conference room and they said, hey, come, use it when you want. And then at the end of 12 months, they're like, well, who used it? And it's just, the IT guys. That's not what happened here. They basically empowered everyone, all the stakeholders on the owner side, the maintenance folks, the design consultants that they work with, the electrical and the mechanical trade partners. They said, hey, we're going to do VR reviews after coordination is done and before we sign off. So they really defined, when it fits into their process and what they're looking for as well. They kind of have these things that they want to look out for that they know historically they're not catching in coordination. And so, a very deliberate plan. And in the first 3 months after switching over to our software from another software, we were talking to them. We went through, a lot of the issues that they had found, and they had saved 3 million. Well, they had prevented $3 million in rework in just 3 months. And it's been more than 3 months, so that number is a lot higher. And they were up to something like 35, I think, VR headsets that they were using in a completely distributed project, which is, I think, is another powerful topic to address here. Is you don't have to be in the same room, and you'll see that shortly with the demo that Sid and I do. We're not in the same. I don't think we're in the same state. Definitely not in the same office. I'm at home. We're going to put our headset on, and suddenly we're going to be walking through this project together as if we're out at a virtual site. So they had 35 people all reviewing. It was awesome. And I think it boils down to, not a misconception, but a mistake that some people can make, which is not having, a plan for how you're going to deploy VR. And it doesn't even have to be, I don't want to scare people here into thinking like, oh, if we're going to adopt VR, it's got all this overhead. We have to plan for it. No, but just look, answer who, what, and when, and you'll be okay.
Yeah, and I think it's a good segue to my next question about the ROI on these technologies that we adopt, right? I think I wanted to understand how you measure it, and I think you touched upon it in your last answer. But if you want to elaborate more on if someone's getting these technologies and wants to understand really what's the return on investment, okay, I buy 10 VR headsets, how is it going to pay off? What are the advantages in terms of just to measure it? What's the metric here?
Yeah. Well, it's typically in avoided rework, right? That's the one that's easiest to quantify. Is people will go into VR, they will find issues, and in Resolve you can use speech to text to basically mark up what we call annotations while you're in the model. And then you look at your annotations and you say, okay, either how much would that have cost us if we had caught it in the field and then had to rip things out or reorder materials, schedule delays, or in the worst case scenario, how much would that have cost the owner if that makes it post turnover? And let's say we're talking about a water treatment facility. There's some catastrophic disaster and they can't access a shutoff valve when they need to, right? So it's all like, what I think VR is doing is it's massively helping reduce the risk, right? Because the further you get into the construction process, like the risk just piles on if you haven't found something. And the worst case is that it makes it into the operation life cycle of the building. So that's one of the big ones, just like looking at what types of issues you have found. And then there's more secondary effects as well. We've had customers tell us that it's cutting down their BIM QA QC process time substantially, because they can go through and audit things a lot faster. They have more eyeballs on different things, and so they're kind of surfacing these issues and resolving them a lot more quickly. There's also the travel and sustainability implications, right? If people don't have to take airplanes and cars to all be co-located all the time, I think that helps quite a bit. And the other, angle to sustainability ROI here is also, if you cut down on the amount of rework, you also cut down on the amount of wasted materials, and materials, obviously to manufacture has a environmental impact, but then also to transport additional materials that you don't need is just inefficient. So those are some of the things that we like to preach to our customers.
Yeah, definitely. I mean, doing things right the first time is essentially the most important thing.
Yeah, measure twice, cut once, right? But this is that to the next level.
Yep. Next thing I wanted to cover is obviously these headset are standalone headsets, but obviously we have a whole plethora of data in this BIM models. I wanted to understand what are the prerequisites if, say, someone is wanting to get into using VR tech. What are some prerequisite data that they need to capture through different softwares for it to have like a seamless integration or seamless use?
Well, uh, honestly, I don't think people need to add much. Most BIM that I see is pretty good. Um, I'll caveat this by saying, look, our focus is not on that Hollywood BIM style. So, if you're using Resolve and for the use cases that I've just mentioned, it's not like you have to go in and say, oh, make sure your materials are accurate and you have the right reflectivity on everything, because that's not what our software is for. And, the sort of space that I focus in. Um, I think most of the modeling, maybe like shift in mentality that I see our customers have is just they're more thoughtful about how things are modeled because they know that at the end of the day, this model is going to be reviewed in VR. One of my favorite examples to give people, and this is a little further, upstream earlier in the design process, but in Revit, a lot of people place exit signs in a 2D view. So it's, like a reflected ceiling plan or some top down view, and they'll go in and place exit signs everywhere. Um, and for the purposes of a 2D drawing, it's fine. It, the PDF looks great. The printout looks fine. The exit signs are where they need to be. You know what room they're in. The problem is a lot of people don't realize that they are snapping the exit signs to the floor. And so once that model ends up in VR or you're doing some sort of 3D walkthrough, immediately one of the questions that come up is, hey, what's wrong with your software? Why are the exit signs on the floor? And we're like, well, let's go look at the Revit model. Oh, they're actually snapped. Like the reference is the floor, but it's one of those things where if you're not really reviewing in 3D, it doesn't matter. And so, there's just little things like that if you're going to be doing a VR walkthrough, you just have to be more mindful of. And historically, one of the biggest challenges to the industry was just the sheer size of models. If you're working on data centers or massive stadiums, large healthcare campuses, manufacturing facilities, these types of buildings have massive MEP systems, very complex. And the later you get into the coordination process, you end up with manufacturing models and trade models, which become even more detailed. And 5+ years ago, these VR headsets couldn't handle those models. And so people either needed to invest in very expensive computers, but even then had to spend a lot of time, cleaning up models, a lot of, if you're listening and you've gone through the VR process, a lot of like decimation and like simplification of meshes and, oh, hide that chair because it's too dense or this and that. And that's really where Resolve, we disrupted things, is we spent a few years working on an engine that could render pretty much anything you throw at it, right? Any BIM file will render, and it's not like we are asking people to go out and buy massive computers. All you need is, again, this wireless headset. All our technology runs on that device itself. And so when we talk to people, we like to remind them, hey, you don't have to worry about any additional modeling process here. Anything you do to your models, you're going to do it because you want to, not because you have to, right? So, as an example, one thing that our customers do more of these days because they are using, VR more regularly is they're like appearance profilers matter a little more in Navisworks. They want to make sure, that hot water return is a specific color, or if you're in a healthcare project that the med gas has specific color codings and it's consistent because they know they're going to be reviewing it in VR. And when someone looks up and says, hey, why is this pipe pink? Well, there's an answer, and it's like, oh, because this is the key, to it. And so it's just to help understanding. But yeah, anything really is just for improving the understanding of the models in VR. It's not like people need to change the way they model because it needs to be VR compatible.
Is there any size limitations of the BIM files that these standalone headsets need to like render? Is there a limitation, or it can just doesn't matter?
Um, I mean, there is like they can only fit. Well, it depends on which headset you have. There's like a 256 gigabyte storage limit, but no one's producing a 256 gigabyte file. We our engine, there really is no limit. Again, the limit is just storage, but no one has run out. The way that rendering works is it's all based on polygons or triangles. Like how many triangles can you render? We've had people upload 1.5 billion polygon files that then open on a Quest with Resolve. The only thing that has to happen is like they download the file, and then once the file is on the device, they're walking around, and Resolve is doing its magic with what we call our Wellington engine behind the scenes to just render this huge file without you really noticing. We take our rendering frame rate pretty seriously. So it's not like if you upload a 1 billion polygon model, you can expect that it's going to run at 5 frames per second. It's going to make you sick. We like to abstract all that away from people so that, it just works. It works comfortably because, like I said before, otherwise VR starts to get this reputation of, oh, it makes you sick, right? I don't ever want to use it again. So we have to be really careful about that. So to answer your question directly, with Resolve, there's no limits. The headset does have physical limits with storage, but we have yet to meet anyone who will break that. And I would say most projects in the industry will be well within the realm of what our software can definitely handle and what the hardware can store.
Moving to the most exciting part of the session, the demo.
I can see you, Sid. You can see me.
Perfect.
Hello.
Hello.
So now we are in a
Mm-hmm.
Navisworks model. This
Mm-hmm.
is running the Resolve application on Meta Quest. You saw how easy it was. You just download the app and then you join the project, and that's it. Everything else loaded automatically. This model is being pulled directly from Autodesk Construction
Mm-hmm.
Cloud, ACC. So our
Mm-hmm.
software has integrations with ACC, with BIM 360, and with Procore, so that you can pull any of your files directly into the headset. And so if my team were to update this
Mm-hmm.
model, it would automatically update
Mm-hmm.
in VR. So there's no like export to VR button or process. It's all
Got it.
automatic. But of
Got
course,
it.
if people don't use those services, they can also just upload their files directly. All right, so I'm
Sweet.
going to teach you very quickly how to move around. So on your right hand, there's a purple joystick.
Mm-hmm.
If you move
Mm-hmm.
that left and right, you will
Mm-hmm.
rotate
Got it.
left and right, so you don't have to move around too much. But of course, remember you can
Got
use your
it.
head to look around,
Mm-hmm.
and everything. The camera moves automatically. A lot of people,
Mm-hmm.
believe it or not, forget to look around. They're so used to like looking at
Mm-hmm.
Navisworks on the screen that they just want to look forward. Exactly. And now to move, on your right hand, if you press forward on the purple joystick and hold it down, you're going to see a dashed line like what you see coming from me here. Yep. And wherever you aim that when you let go, you will teleport. So this is just a way to move around that is just proven to not make people motion sick. Because the next way I'm about to show you, that's a more of a advanced technique. But if you're new to VR, can sometimes make you a little bit motion sick if it's your first time. So on your left hand, there's a yellow joystick. If you press forwards on that, you will
Mm-hmm.
walk forward. There you go, or back to back. That's right.
Got it.
So if you start to feel a little bit, uneasy, just stick to the teleporting. All right. The next thing I will show
Sweet.
you is on your right hand, on the purple joystick. If you push that into the controller, so you press it down, you will fly up. Yeah, there you go. So this is where you start to get superpowers in VR, right? So if I'm with you, you're, let's say, a mechanical operator, and we want to talk about the HVAC up here, we can just fly up. And this is something that would be impossible to do in real life unless we had a lift. And now, we can go up here and talk about some of the ductwork, see, if I had a lift or a ladder, is it accessible? Is it safe? And, ask ourselves these questions. And when a lot of people ask us, why do I need this? I already have Navisworks, right? What can this do differently? I'm going to take you down here, and I'm going to use our gather functionality to bring you here. So I'm able to gather you as well. One of the things you can do in VR that you just can't do in Navisworks unless you end up building a physical prototype is simulate things that a human has to do. So in this case, maybe it's reaching into the assembly line and see, hey, what is it like to get items on and off the line if I'm an operator or if I'm one of the workers here, or maybe even I'm one of the installers for this manufacturing line. What are some of the logistics things that I might run into? And I can practice that procedure with my hands, with my body. I don't know how much space you have to move around, but the Quest 3, it is tracking your position. It has cameras, so you could get up, and as long as you're within your boundary, you can walk around and see, hey, what's it like to walk over here? Is it safe? Am I going to hit my head on some piece of equipment? Those are all things that are a little bit more difficult to see if you're just looking at one person's screen on Navisworks, which is, the traditional way that things are done.
So this entire model is 1:1, right? So essentially it would detect all the spaces and everything.
That's right. It's 1-to-1. And then when you see my avatar, let's say you are the person who is in charge of this manufacturing line, and you're asking me to pretend to do a maintenance procedure. You can see my avatar as I'm here doing things, and you can see, why are they having to reach for this thing, or it looks like they're not going to fit. And then you go back to your team and hopefully address those changes.
Got it.
Okay. I also want to show you. So if you hit the create button, that's the big plus button in the middle. So there's a couple of tools here. So the most important one, I think, is the speech to text annotation. So if we found something wrong in the model, you want to be able to record that, right? We don't want to just go into VR and then everything gets lost. So let's say that, actually, I think there's a really good example over here. Let me see if I can find it. Yeah, right here. I will bring you to me. Just give me a second. Let me fly over here. Okay. Over here, there's a really good example where in this staircase, once you start to get to the top, there's a very sharp corner here. If you can see it, there's a very sharp corner and not much clearance to the stairs.
Yep.
I can actually use our measuring tool to measure that. So between the stairs and the ductwork, there's about 5 feet, 5 inches. Someone's going to get hurt there, right? So if I'm walking up these steps and I'm walking here, this corner is either going to get me on the way up or right behind my head, and that would be very bad. So let's say we're in here, we find that we want to flag it now for our team to fix. So you go to the create menu, you hit, I'll let you do it. So once you hit add speech to text annotation, it'll count down, and then you just say whatever you want.
Not enough height clearance. There you go. Sweet.
Cool. And so then you go ahead and you just pick a tag for it.
So I'm gonna say design. Next.
Cool.
Boom.
And now I see it, number 88 by Sid, not enough height clearance. And once that gets added, we can always return to it in Resolve. But like I was saying before, Resolve has integrations with platforms like ACC and Procore, so we could push this out to our issue tracker. We also have ways to export the annotations as a BCF, so then you can go into Revisto or Nuforma Connect, or You can also export a Navisworks viewpoints XML. If you just want to bring it into Navisworks and look at them as viewpoints, that's fine, or CSVs and PDFs. We have many ways of getting these out of VR because we know people have, these parallel issue tracking processes, and we want to make sure they use Resolve to find more issues and then use their existing tools to make sure that those are closed out. So now you've seen, sort of one of the quickest ways to get in, find an issue, mark it up, and when you left that behind the scenes, the software took a picture of what you were looking at. So when you sync it to, let's say, Procore issues, it'll include the screenshot with it, and that way, people know they have context for what you're looking at. With the integrations as well, we export out the 3D coordinates. So if you go look at the model on the BIM viewer or your computer, it will take you to the same spot of the annotation.
Oh, got it.
And then I briefly showed the measuring tool. There's sketching. There's maybe one of the last things I'll show you here is this is all BIM, right? So it brings with it information, metadata. If you aim at the ductwork and you double click with the blue trigger, it will highlight for you. Yep. And then it'll bring up the properties menu. And here you can see all the metadata associated with it. So you asked me earlier, what should people do differently with their models? Does this change anything? One of the things we do see is people are a little more deliberate about their properties, make sure that it doesn't have too many useless or empty fields, make sure people understand what's in there, because this can be super useful to get more context, right, about what exactly am I looking at.
Sense.
And I can hide it. So I can start to hide, individual objects, say, okay, we found this issue. What if we were to hide that duct? Okay, well, now it looks a lot safer. We now just have to figure out what are we going to do with the piece that we removed.
Got it.
Yep. And there's also a bunch of layers associated with everything. So you can see I'm going to start turning off generic models, mechanical equipment. What else can I turn off here? Well, actually, let's do this. I'm going to start to turn off doors, electrical. I'm going to leave just the duct for the most part. Landing level, plumbing. Yeah, so I've taken the roof. So you can see I've peeled back some of the layers here. I've turned off all the robot arms, and maybe I'm the trade partner in charge of installing the HVAC. So this is all I want to look at. Well, I can do that all in here. Okay, the last thing I will show you is, let's go to Dollhouse. I'm going to take you up to what's called our Dollhouse view. Okay, so up here, we can look at the model in this tabletop view. So you can see the models down here. And I have a section plane I can cut in and out. And I'm actually going to turn everything back on. And so here, if you lean in or move forward, now we're looking at a top-down view, right? So this is a little bit more like what people are used to seeing on their Navisworks screen, where they zoom out and they zoom in. But you can move the model around. We can scale it up and down. If you squeeze both of your green controllers, green buttons on your controllers, yep, you can grab the model. There you go. And now you're moving it around.
Perfect.
And then we can choose, maybe if we had a bigger, campus or something, we can say, I actually want to go here. And you can teleport down to a specific section of the model.
Wow.
Yep. And then a new feature that's actually coming out by the time you publish this actually is, if you look over here, we have these 2D documents. So we are adding what is called an app portal so that people can access Procore, ACC, BIM 360, Newforma, all inside of Resolve without taking their headset off. And then they can pin up pictures, screenshots of what they were looking at. So here, I've put up in my dollhouse room a sample reference one-line diagram for some electrical equipment. But people can put up whatever they want and kind of customize this area, or put some drawings down there, and now they can access that 2D information that's still very important to them.
Awesome.
Any other questions, Sid?
No, I think I'm just impressed. I mean, this is pretty awesome. I could see a lot of great use cases. Yeah.
That's awesome to hear. Yeah, well, I'm glad you were able to jump in here with me. Bye, Sid.
Bye bye. Wow, this was awesome, Angel. I mean, this is a really good tech. I think it's I, yeah, I think it really comes down to that education bit that I mentioned. More people as they would know, because it's super. I mean, I was using it for the first time and it felt super easy to navigate. Obviously, there's more to, like, if I use it a couple times, I would navigate it a bit more, much more better. But this is awesome.
Yeah, very easy to pick up, and I think you're right. It's just people need to know about it. People need to go in there, and then usually they don't want to give the headset back after that.
The last question that I had is, what's the current state of VR, and what does the future look like as the technology advances?
Yeah, the current state is very exciting. I feel like there's some of the best energy we've had in the last few years because, again, it's so accessible. And this year, Apple entered the game, which I think also got a lot of people reinvigorated about the technology. Historically, it's been Meta, it was HTC, it was, Pico slash ByteDance. And not that those companies aren't good companies. They're all great partners that we've worked with before. But the Apple brand does carry some weight to consumers, to enterprises, right? And so seeing them enter the the field, so to speak, I think has injected a lot of exciting energy. I think there's a lot of things that they nailed. I think there's a lot of things that they'll hopefully also improve with Vision Pro. But the things that they got right, I think, are inspiring everyone in the industry. To try to strive for that level of quality, the interactions, the stability. I think there was something very exciting there. And Meta keeps doubling down on the hardware, which is also really exciting. They are ultimately the ones that acquired Oculus, and I'm so grateful that they didn't just give up on Oculus. Mark Zuckerberg has this bold vision. Whether you believe in the metaverse or not, I think the reality is that Mark Zuckerberg and Meta are pouring billions of dollars into the R&D of this tech, and in many form factors, right? So you've got the consumer stuff that we've shown on the screen, the Quest 2s, the Quest 3s, and their successors. But then they're also doing really interesting things with like their Ray-Bans glasses, which take videos, and that's like a form factor that people want, right? These glasses that you can wear all day that look like normal eyeglasses, but are doing advanced things for you. They don't have a display, but people seem to love them. And then they also show off prototype hardware as well internally, whether that's things to interact with virtual content in new ways, or some of their more intense looking, larger devices with like bigger fields of view, higher resolution displays. So yeah, I think Meta's also doing a lot of really exciting things at the forefront of hardware and now AI. And I think AI is the buzz as well in Contech. I think it's not going anywhere. I think you'll also start to see it converge with some of these spatial applications. There's so much rich data out there. Like I said before, that's what has really enabled technology like VR and AR to have some sort of traction in construction. Is the data was already there, and I think that also extends to a lot of the AI LLM advancements as well. It's like there's so much rich data to learn from, to summarize. Frankly, I think there's a bit of a data overload problem in the construction industry. Projects produce so much data, some of it that like probably rarely gets looked at by more than one person. But if you can condense that and get the right information to the right people at the right time, you start to make way better use of all that data that is being produced in the industry. So yeah, I think that it's a very exciting time. The last thing I'll say here, kind of taking it full circle to the beginning of our conversation, I think people just have to be aware of the fact that with hardware and software in this space, it is not one size fits all, right? So just like your computer, you will have some applications that do one thing well. You will have some applications that are great for field augmented reality. You will have other applications that you use internally for your coordination of fly-throughs. You will have some applications that you use if you want to do actual 3D modeling in VR. You will have some applications that you use if you want to load massive 3D files, right? It's like there will be the Revit, there will be the Navisworks, there will be the Tekla. There will be many applications, and I think right now it's important to be open-minded and not try to say, oh, we want one software that does it all. I think people do have to be focused about how they're applying this tech and which solutions they are applying, to whatever they're trying to achieve.
Well, really appreciate your time, Angel. I think this was super interesting and insightful, and I'm pretty sure all the viewers watching this would learn a thing or two from this. So thanks again.
I hope so. Thanks for having me.
Thank you for tuning in to Constructing Tomorrow. I hope this episode provided valuable insights and tips. Don't forget to like, share, subscribe, and drop a review or a comment. Until next time, keep building and stay curious.